This is a quick tutorial on reverse engineering communications protocols using an oscilloscope. By the end of this video, you'll be analyzing real-time data packets from a GameCube controller, watching the signal change as you press buttons, and learning how the controller talks to the console. Because we're going to be stripping cables, I recommend using an extension cord rather than the actual controller itself. To start, we remove the outer covering of the cable using the 10-12 hole of a wire stripper. With the inner cables revealed, you can choose the data and ground wires. In my case, it is green and red, but that can vary depending on the extension's maker. So with those revealed, I then use another wire stripper to get the 26-28 hole and strip them. They're much easier to strip because you just need to reveal a little bit of the wire so the oscilloscope's probes have something to connect to. And with those revealed, you can then take your oscilloscope's probe and connect them to the data and ground wires. And with that done, we're able to then analyze the signals with the oscilloscope. With the oscilloscope on, you might see something like this, which doesn't look like much. But after adjusting the vertical and horizontal scaling, something that could be a data packet starts to appear. However, as you'll notice, the signal is dancing around the screen. What we can do to fix that is to set some triggers. So what we can do is we can set a trigger to occur on the falling slope in this case and adjust the triggering level down, which makes it much easier to see what's going on. With it adjusted like that, we can now start to press different buttons on the controller and notice how when we hit different buttons, the data in that packet changes. We can see the signal change, but what does it mean? We're looking at changes in voltage across the data cable. These signals take two forms: periods of the voltage being primarily low, which encode zeros, and periods of the voltage being primarily high, which encode ones. Each of these data packets is actually two separate data packets. The first 24 bits are a command from the console. The controller responds with ones and zeros that convey information about the state of the controller, including which buttons are being pressed and the position of the joysticks. By tracking this cause and effect, you can build up information about how the controller communicates with the system. And at this point, you've got everything that you need to decode the protocol, or even build your own GameCube controller from scratch.